All right, so we have the graph. That's what the graph should look like right here. When I told you the graph, here's the function. Of course, that's y equals 1 minus x. That was the graph. And remember, we revolving each each one of those rectangles. That's an example of a rectangle that's in that area with its height being x and that little change being dy. So if I revolve this, if I revolve it around the y-axis, then I'm going to get a cylinder around that y-axis. Just picture that being a 3D cylinder around the y-axis, where each radius is going to be x now, and the thickness is going to be dy. So when I go to integrate, I'm going from, remember it's bounded by the x-axis. So that's where y is equal to 0 and all the way to where y is equal to 1 right here, that point. Remember I said everything in terms of y. And remember it's pi times each radius squared times the height. Remember the radius we said was x. So I have to take this and solve for x, and I think we already did that. You told me that you had that already. That x was equal to 1 minus y. So of course that's going to go in the place of r right here, right? So I'm going in that place. And the height, remember, is dy. That's that change. So when I go to plug in, I should have 0 to 1, the integral from 0 to 1. And we factor out our pi. And that's the r squared. So we know is 1 minus y, all that squared, dy. So remember on that last text I told you we had to do a u substitution. See, you was talking about factoring out this 1. You probably thought you could square each term, but we can't do that. Remember in algebra, when I have a binomial, if I'm a square, that means 1 minus y times 1 minus y, but we don't have to do that anymore because we know we could do u substitution. Remember when we talked about making u that inner function? If I make u 1 minus y, that's the inside function. Then du is the derivative of that. I already know the derivative of 1 is 0. The derivative of a negative y is a negative dy, right? I have dy, I don't have the negative. So that means that negative du equals dy. So I know when I go to plug this in, this negative 1, understood to be a negative 1, is going to be factored out. So outside by this pi, so that's a negative pi times the integral. That's too far. Times the integral from 0 to 1. Still, well, technically it won't be from 0 to 1, because remember we put it in u, in terms of u. So if I plug in 0 for y, that's 1 minus 0 right here. So that's going to be 1. And this right here, if I plug in 1, at the top is going to be 0. Uh, all of that was u squared Remember dy, we said was negative 1 du, but we factored out that negative 1. So it's just du. So when I go to integrate this, it's going to be a negative u, I'm sorry, negative pi times the quantity. And we add 1 to the coefficient, divide by the new one, so it's going to be plus 3. So that's 1/3 u to the 3. Tested from 0 to 1. Now, really, you know, when the a is smaller than the b, we were supposed to flip it and negate it. But for the sake of time, we really don't have to do it. You can just plug in. So if I plug in for u, when I plug in 0, all of this is going to be 0. But remember, it's f of b minus f of a. So I'm supposed to subtract that second part. So when I plug in this 1, I'm supposed to be subtracting all of this. So subtracting a negative means I'm going to have a positive. So that's pi times 1/3. And we plug it in for 1 u. So that's 1 cubed. Bad. Fix it up. So 1 cubed is 1, of course, times 1/3, and times pi. That's equal to 1/3 pi. So right here is that algebra that I'll be telling y'all about. You can't square each term right there. So I had to do a u substitution.